Hello, this is Dr. Hanaa Assil, and this is paper 1CR of January 2023 in the Pearson Edexcel IGCSE chemistry. So let's take a look at the questions and discuss the answers. The diagram shows how the particles are arranged in the three states of matter. Use words from the box. So you're choosing words from the box to identify X, Y, and Z. So what is X? X is the change from liquid to gas, so that is evaporating. What is Y? Y is from gas to liquid, so that is condensing. And Z is liquid to solid, so that is freezing. Please, in these kinds of questions, please notice the direction of the arrow. Okay, the next question says, describe the differences in the movement of particles in solids and gases. So he's asking about what? He's asking about solid and gas, and he's asking about difference in movement. So please don't mention anything else. Don't talk about arrangement or separation. He just wants movement. So how do the particles in a solid move? They vibrate in fixed position. Gas particles, they move fast, free, random motion. So this is movement of particles. The next question says, this is about gases in the atmosphere. Name the most abundant gas in the atmosphere. Remember that the word most abundant means the one that is present in higher percent. So you should know that the atmosphere is mostly nitrogen. It is about 78% nitrogen. Name the noble gas that makes up about 1% of the atmosphere. Remember that the gas that is about 1% is argon. Name a greenhouse gas in the atmosphere. Which gas in the atmosphere causes greenhouse effect? Carbon dioxide gas. A student uses this apparatus to determine the percentage of oxygen in a sample of air. This is the student's method. Measure the initial length of the column of air in the tube. Leave the apparatus for 1 week. Measure the final length of the column of air. So what is happening in this tube? You can see that we have iron wool, and the iron wool is wet, so it has water. And it is exposed to air, so it has oxygen. And when you have iron with water with oxygen, what happens is the iron rusts. So it changes into hydrated iron 3 oxide. This is the name of rust. So he is giving me results that the initial length of the column was 84 millimeters. Now, after the iron has used up oxygen from the tube, the final length of the air is 69 millimeters. So, first of all, state the appearance of iron wool after 1 week. So, if we put the iron in, it's wet, so it has water and it has oxygen, it rusts. What is the appearance of rust? Remember that metals are normally, or iron is normally silvery metal, but when it rusts, it becomes reddish brown. Then he's saying use the student's results to show that the percentage of oxygen in the sample of air is approximately 18%. So we look at the table. This was the table he gave us. The initial length of air was 84. After we took away the oxygen, it became 69. He wants percent oxygen. How do I calculate the percent oxygen? The difference over the initial length, the difference over the original length times 100. This gives about 18%. The actual percentage of oxygen in air is about 21%. Give a reason why the percentage of air calculated from the student's results is less than 21%. Why did he get 18% instead of 21%? That means that not all the oxygen reacted with the iron. We did not give the experiments enough time for all the iron to use up all the oxygen in the air. Question 3 is talking about alkanes, and he gives me the structural formula of an alkane. What is the name of that formula? Of course, to name an organic compound, we count the number of carbons. So this has 4 carbons, so that means its name should start with but, and then this is an alkane, so this is butane. And then he's saying, what is C4H10? Remember that any organic compound, we have different types of formula. We have displayed formula. This is where we're drawing everything, showing all atoms and all bonds. We have structural formula. So this is the structure formula for propene. Structural formula, we collect all the hydrogens for each carbon. So the first carbon has 2 hydrogens, and then 1 carbon with 1 hydrogen, and then 1 carbon with 3 hydrogens. That is structural formula. Molecular formula is the one showing all the number of carbons and all the number of hydrogens. So C4H10 here is a molecular formula. What do we mean by empirical formula? Empirical formula is the formula showing the simplest ratio. So if I say that the molecular formula is C4H10, what is the empirical formula? You simplify 4 to 10, so you can divide by 2. So that is C2H5. So that is the empirical formula. And then when we say the formula of something is CnH2n or CnH2n plus 2, so this is called general formula. So you should know that the general formula of alkanes is CnH2n plus 2, while alkene like propene up there, the general formula is CnH2n. There are 2 isomers of C4H10. What is meant by isomers? You should know, and please do not mix up isomers with isotopes. We're talking here about isomers. Isomers are organic compounds with the same molecular formula but different displayed formula. Same molecular formula, different displayed formula. How do we draw an isomer of an alkane? Remember, alkanes have only single bonds between the carbons. So if I want to draw the isomer of C4H10, either I draw all the 4 carbons in a straight chain, so this is one isomer, or I draw 3 carbons and the 4th is a branch in the middle, so that is the second isomer. Please be familiar with these. Methane reacts with bromine to form bromoethane and one other product. Give the formula of the other product. So we're talking about methane. Methane is an alkane, and you should remember that when alkanes react with halogens, we remove one of the hydrogens and put one Br so that the other product is HBr or hydrogen bromide. Now, what is the name of this type of reaction? You should know that this is called a substitution reaction. So alkanes with halogens do substitution reaction. What is the condition for substitution reaction of alkanes? UV light, ultraviolet radiation. When ethane burns in a plentiful supply of air, carbon dioxide and water are formed. Give a chemical equation for this reaction. So we're writing a chemical equation for what? Remember the word first, chemical equation means symbol. If he does not mention word, he does not want word equation. He wants a symbol equation, and you have to remember that a symbol equation must be balanced, even if he does not say that. So what are we trying to write? Ethane, he already tells me that ethane is C2H6, and he wants to react it with air. So he's reacting it with what? With oxygen, and oxygen is diatomic, so that is O2. to give carbon dioxide, which is CO2, plus water, H2O. I have to balance this equation. Now, if you sit down and balance this equation, you will find that you will need to put 2 in front of the ethane. This makes 4 carbons before the arrow, so you have to put 4 carbons after the arrow. You have 2 times 6 hydrogens before the arrow, so you need 2 times 6 hydrogens after the arrow. Now, how many oxygens after the arrow? I have 2 times 4 is 8 plus 6. 14, so I need 2 times 7 to make it 14 oxygens. When the air supply is limited, incomplete combustion occurs. Explain why a gas formed by incomplete combustion can cause a problem for humans. So first of all, what is the gas formed by incomplete combustion? You should realize that when we have incomplete combustion, I form carbon monoxide. Carbon monoxide is formed, and this limits the capacity of blood to carry oxygen, so less oxygen is carried to body cells, and the cells cannot do respiration. So we say carbon monoxide is toxic. Why it is toxic? Because it limits the capacity of blood to carry oxygen. A student investigates the effect of temperature on the rate of reaction between 2 solutions, A and B. When the reaction occurs, the mixture turns from colorless to blue. So he has a reaction between A and B, and he says when they react, it turns to blue. And then he's going to change temperature and see the effect of temperature on rate. So what did he do? Pour 25 centimeter cubed of solution A into conical flask. Add solution B. Measure the temperature of the mixture. Record the time taken for the mixture to turn blue. The student repeats this at different temperatures. So, which 2 variables does the student need to keep constant? What do I need to keep constant? Every time I change temperature. Remember, we're repeating the experiment with different temperatures, but they should have same what? They should have same concentration of solution A, or concentration of solution B, or volume of solution B, because he already put 25 centimeter cubed of solution A. Now the volume of solution B that we add should also be the same every time you repeat the experiment. The table shows the student's results. Plot the student's results on the grid. Draw a circle around the anomalous result and draw a curve of best fit. So if you sit down and plot the student's results, you will find that these are the points that I have. Obviously, he wants it to be a curve. So when I connect it, the point that is away from the curve, that is my anomalous result. Then he's saying, give a reason for the anomalous result. Why is it, do you think, that the student got a value lower than the curve? So he got a time, the time that he measured is less than what it should be. So what do you think may have happened? Well, maybe he started the timer too late, then the time he measured is less than what it should be, or he took the reading too early at the end so that he did not get the correct time. Then he says, use your graph to determine the time taken for the mixture to turn blue at 55 degrees Celsius. So where is 55 degrees Celsius? He wants at 55. He wants to know what was the time. So you draw a line from 55 going up to the curve. Draw a horizontal line to determine the time. So according to this graph, the time taken is 117 seconds. Please make sure you show him how you got your answer. So you have to draw these lines that I drew in red. You have to draw them on your graph to make sure that he understands how you got your answer. Show your working on the graph. Then he says, use the information from the table to calculate the mean rate of reaction at 20 degrees Celsius. And he gives me the equation. So he's saying the mean rate is 1 over time. So I go to the table and I find out at 20 degrees Celsius. What was the time? The time was 156. So the rate is 1 over that. So that gives me an answer of 0.0064. Is that my final answer? Give your answer in standard form. So the answer should be in standard form. So this is 6.4 times 10 to the minus 3. Explain how increasing the temperature affects the rate of a reaction. Refer to particle collision theory. So if we increase the temperature, he's telling me explain how it affects. So you have to tell me how it affects and why. So how do we answer this? Remember that when we increase the temperature, how does that affect the rate? Increasing the temperature increases the rate. Now explain why. You should know that when we increase the temperature, particles gain kinetic energy, move faster. More of the molecules have energy higher than activation energy, so we have more successful collisions per minute, or more frequent collisions that are successful. This question is about organic compounds. The diagram shows the displayed formula of methanoic acid. Now, give the total number of atoms in this molecule. Remember that sometimes he says give the total number of atoms, and sometimes he says give the total number of different atoms. So here he wants the total number of atoms. So I have 2 hydrogens, 1 carbon, 2 oxygens. I have a total of 5 atoms in this molecule. Determine the relative molecular mass of methanoic acid. You should know how to calculate relative molecular mass. You look at the periodic table. You choose the mass number for each one, the bigger number for each one. So if we have 2 hydrogens, the mass number of hydrogen is 1. I have 1 carbon, its mass number is 12. I have 2 oxygens, each of them have a mass number of 16. The total of that is 46, so that is the MR of methanoic acid. Explain why methanoic acid is not a hydrocarbon. So this is methanoic acid. Why is it that we cannot say it's a hydrocarbon? This is because hydrocarbons have only carbon and hydrogen, but methanoic acid has carbon, hydrogen, and oxygen. So please mention that the fact that methanoic acid has oxygen and that a hydrocarbon should have only carbon and hydrogen. Okay? The atoms in methanoic acid are held together by covalent bonds. State in terms of electrostatic attractions what is meant by the term covalent bond. Remember that in covalent bond we're sharing electrons. So what is the covalent bond? Or sometimes he says how are the atoms attached together or held together? The covalent bond is the strong electrostatic attraction forces between the pair of shared electrons and the positive nuclei of the atoms. So the shared electrons are negatively charged. The positive nucleus of each atom is positive, so there is an electrostatic attraction force between the shared pair of electrons and the positive nuclei of the atoms, both nuclei. Draw a dot and cross diagram to show the bonding in a molecule of methanoic acid. So how do we draw a dot and cross diagram for this molecule? Remember that we have hydrogen has 1 electron, it needs 1 from the carbon. Oxygen needs 2 from electrons from the neighboring atom in order to have a total of 8. So this is the kind of dot and cross diagram that you should have. Please remember that each atom should have a different notation. So you should have a notation for hydrogen, a notation for oxygen, and another one for quark. Okay. Calculate the empirical formula of the organic compound with this composition by mass. If he gives me percentages and he wants empirical formula, we said, how do we do that? You write the percentages. The first thing you do is divide by the mass number of each one, the big number. Please do not divide by the atomic number. You divide by the mass number, that's the big one from the periodic table. So carbon is 12, oxygen is 16. The numbers that you get after that, you divide by the smallest. So I got 4.35, 13.0, 2.175. Which one is the smaller? 2. I divide divide each of them by 2.175. I get this ratio, and that means, please don't stop here. That means my empirical formula is this: C2H6O. The 1 is not written. Don't write O1. We never write a 1 under it. It's understood that there is a 1. Okay, this question is about elements in group 7. Which element is a liquid at room temperature? Remember, you should know the appearance and the color and the state of each of the group 7. So, for example, which of these is a liquid? You should realize that fluorine is a yellow gas, chlorine is a green gas, bromine is the liquid. Bromine is a reddish brown liquid. Now, what color is solid iodine? You should realize that solid iodine is gray. It's a gray solid. Describe a test for chlorine gas. What was the test for chlorine gas? Remember, chlorine gas, not chloride. Chlorine gas, you insert damp litmus paper, which should really be blue. Insert damp blue litmus paper, it bleaches. A sample of chlorine containing 2 isotopes has this percentage composition by mass. So he's telling me I have 2 isotopes of chlorine, one mass number 35. Remember these numbers 35 and 37, that is the mass number. So one isotope of chlorine has a mass number of 35, and that is 71.2% of chlorine atoms. Now the other isotope has a mass of 37, and only 28.8% of atoms has this mass number. Now calculate the overall relative atomic mass. Of course, how do we do that? It is the mass times percentage of the first one plus mass times percentage of the other one. This gives you 35.58. Again, please don't stop here. He's saying what? Give your answer to 1 decimal place. So if you don't write it 35.6, you lose a mark. Okay? A student is given an aqueous solution of chlorine and an aqueous solution of sodium iodide. Explain how the student can use these solutions to compare the reactivity of chlorine with the reactivity of iodine. So we have chlorine solution and sodium iodide solution. Now, how do we use it to determine which one is more reactive, chlorine or iodine? First of all, we're going to start with aqueous solution of sodium iodide. Can you tell what would be the appearance of sodium iodide solution? Sodium iodide is a compound of sodium, a compound of group 1. We don't have any transition, so sodium iodide solution is colorless. Now, when I start to add chlorine, what happens? The chlorine is more reactive than iodine, so it will displace the iodine. So now I don't have sodium iodide, now I have iodine solution. So the colorless solution turns brown. Since chlorine was able to displace the iodine, that tells me that chlorine is more reactive. So when you have this kind of questions, you're going to add the chlorine solution to sodium iodide. You should know that sodium iodide originally is a colorless solution. But when you add chlorine, it reacts with the sodium iodide to give iodine. Remember that iodine in solution is brown, so the colorless solution turns brown, and this indicates that chlorine is more reactive than iodine and was able to displace it. A teacher ignites a piece of magnesium ribbon, places it in a gas jar of oxygen. This is the equation. Now give two observations that would be made. What is he doing? He's burning magnesium in air. And you should realize that when magnesium burns with a bright flame. And then it forms magnesium oxide, and you should know that magnesium oxide is a white solid, or we refer to it as white ash. So we say a white solid is formed. So these are the observations, and please remember, observations mean what do we see. So magnesium burns with a bright flame and a white solid is formed. The teacher demonstrates the reaction between aluminium and iron 3 oxide. So the teacher ignites the magnesium fuse. A very exothermic reaction then occurs between aluminium powder and iron 3 oxide. The products of the reaction are iron and aluminium oxide. So first of all, what is meant by exothermic? What does exothermic mean? Exothermic means the reaction gives out heat. Give a chemical equation for the reaction between aluminium and iron 3 oxide. Again, chemical equation means symbol and balance. Aluminium plus iron 3 oxide. How do we write iron 3 oxide? Iron 3 means the valency of iron is 3, and that we put under the oxygen. So valency of iron is 3, you put 3 under the oxygen. Oxygen is in group 6, that means it has a valency of 2, you put the 2 under the iron. Iron 3 oxide is Fe2O3. Now what does this give me? It gives aluminium oxide. Again, aluminium is in group 3, valency 3, so we put the 3 under the oxygen. Oxygen is in group 6, that means it has a valency of 2, you put the 2 under the aluminium plus iron. Then you have to balance. Please do not leave this equation as it is and leave. You have to balance. You need 2 in front of the aluminium because you have 2 aluminium after the arrow. And you need 2 in front of the iron after the arrow because you have 2 irons before the arrow. Now explain why this reaction is redox. Remember we said, when he says this, you have to tell me this is because I have oxidation, which is where, and I have reduction, which is what? So redox means I have both oxidation and reduction. Now, why am I saying I have both oxidation and reduction? Because the aluminium gains oxygen, and that is oxidation, and the Fe2O3 loses oxygen, and that is reduction. Please indicate to him where is the oxidation and where is reduction. A student uses this apparatus to determine the formula of magnesium oxide. So he has magnesium ribbon in a crucible and lid. This is the student's method. He finds the mass of the empty crucible and lid, place some magnesium ribbon in the crucible and find the mass of crucible and lid and magnesium. Heat the crucible, lifting the lid from time to time. After 5 minutes, find the mass of the crucible, lid, and magnesium oxide. First of all, why should he lift the lid from time to time? Remember, I'm trying to react the magnesium with what? With oxygen. So I need to lift the lid from time to time to allow more oxygen in for complete reaction of magnesium. I want all my magnesium to react. I don't want it to run out of oxygen. So I need to remove the lid from time to time to allow more oxygen in. The mass of the magnesium oxide formed is less than expected. Describe what the student should do next to obtain a more accurate value for the mass of magnesium oxide. Remember, he did this only once. He heated it, allowed to cool, and then weighed. But actually, what we should do is repeat that several times until the mass does not change. So we have to keep reheating, cool, reweighing until constant mass. So when all the magnesium has reacted, then the mass will not change anymore. This question is about oxides of some elements in group 4 of the periodic table. When 5.34 grams of lead carbonate are heated, lead oxide and carbon dioxide are formed. Give the name for this type of reaction. When we heat a compound and break it up, this type of reaction is thermal decomposition. You heat a compound and you end up with 2 or more compounds, that is thermal decomposition. Calculate the maximum mass of lead oxide, so he wants mass of lead oxide, that can be formed from 5.34 grams of lead carbonate. So he's giving me information about lead carbonate and he's asking about mass of lead oxide. So what is the first thing we should do? He gives me mass of lead carbonate. So the first thing I should do is get number of moles of lead carbonate. Number of moles is mass over molecular mass. He already gives me the molecular mass. So this gives 0.02 moles. Now, this is the number of moles of lead carbonate, PbCO3. What is he asking about? He's asking about lead oxide. So I look at the equation. What does the equation tell me? The equation says 1 mole of lead carbonate gives 1 mole of lead oxide. So if the number of moles of lead carbonate is 0.02, then the number of moles of lead oxide is the same. Then what is he asking? Mass of lead oxide. How do I get mass? Mass is number of moles times mR. He already gives me the mR of PbO up there. So that means the mass of lead oxide obtained is 4.46 grams. Are we following? He gives me information about something, I get number of moles. And then I relate that from the equation to the number of moles of whatever he's asking about. And then I give him what he wants. Okay? The diagram shows apparatus used to heat lead carbonate. So he's saying that he put the lead carbonate into that tube and he's trying to heat it. Now complete the diagram to show what needs to be added to the apparatus to test that the gas released is carbon dioxide. I want to make sure that the gas that comes out is carbon dioxide. So what should I use to test it? Well, you should know that to test for carbon dioxide gas, I need lime water. So I need a delivery tube going into a test tube that has lime water. What would be the result if the gas is carbon dioxide and passes through lime water? Well, the lime water turns milky. Silicon dioxide and carbon dioxide both contain covalent bonds. Silicon dioxide is a solid with high melting point. Carbon dioxide is a gas at room temperature, and that means it has low melting point. Explain why silicon dioxide has a much higher melting point than carbon dioxide. Refer to structure and bonding. I'm going to remind you that silicon dioxide has a structure very similar to diamond. But diamond is all carbon atoms, while silicon dioxide has silicon atoms and oxygen atoms. Otherwise, it's the same structure. So whatever we said about diamond, we say about silicon dioxide. But carbon dioxide is a simple molecular structure, and that is why it has low melting point. So he's saying, explain why silicon dioxide has much higher melting point. I'm going to tell him because silicon dioxide has so-and-so structure with so-and-so attraction forces or whatever. And the other one has low melting point because of its structure and its bonding. So let's take a look at silicon dioxide. Silicon dioxide has high melting point. Why? It doesn't have strong attraction forces between something. No. It has many strong covalent bonds between the atoms in a giant three-dimensional tetrahedral structure, and this needs a lot of energy to be broken. So silicon dioxide or diamond, if we're saying why silicon dioxide or diamond have high melting point, it is due to the presence of many strong covalent bonds between the atoms in the giant three-dimensional tetrahedral structure that need a lot of energy to be broken. Then, why is it that carbon dioxide has low melting point? Remember that carbon dioxide has simple molecular structure, and this has weak attraction forces between molecules that need a small amount of energy to be broken. This is actually what you need to say for anything that has a very low melting point. So any substance with very low melting point, that's probably because it has simple molecular structure with weak attraction forces between molecules that need a small amount of energy to be broken. A student uses the reaction between zinc powder and dilute nitric acid to prepare some zinc nitrate. Complete the equation by adding state symbols. What is the state symbol for zinc? Well, you should know zinc is a metal. All metals are solid, so its state symbol is S. Nitric acid, that's a dilute nitric acid solution. So all acids are aqueous solutions. Zinc nitrate, he's telling me that I will get zinc nitrate. Remember that all nitrates are soluble, so this is an aqueous solution. And of course, the other product is hydrogen gas, so the state symbol is G. State what the student would observe during this reaction. So he's putting zinc on a solution. He's putting metal with this on acid, and I'm going to get hydrogen gas. If you add a metal to acid and you get hydrogen gas, what do you see? Anything that gives out a gas, what you see is bubbles of gas or fizzing or effervescence. All of these are the same. In the preparation, the student adds an excess of zinc powder to some dilute nitric acid. So he's starting to prepare zinc nitrate. The first thing he did was add excess of the metal to some dilute nitric acid. Why do we use excess? Of course, this is the neutralization method of preparing salts. We use excess of the zinc to make sure that all acid reacts. Then describe what the student should do next to obtain pure dry crystals of zinc nitrate. So what does he have now? He has zinc, excess zinc in a solution. The first thing we do is filter through filter paper and funnel. This is to remove the excess zinc. Then we take the filtrate, because this filtrate is my zinc nitrate solution, do crystallization. So heat the filtrate to point of crystallization, cool to form crystals, filter the crystals, wash the residue then, or wash the crystals with a few drops of distilled water, and dry between filter papers. The formula for zinc nitrate crystal is this. When zinc nitrate crystals are heated, the products are zinc oxide, nitrogen dioxide, oxygen, and water. So he's saying write the equation. So zinc nitrate with 6 water of crystallization. You heat it, it gives zinc oxide. How do I write zinc oxide? Valency of zinc is 2, valency of oxygen is 2, so zinc oxide is ZNO. Nitrogen dioxide, oxygen is diatomic. Please don't write just O, it is O2, and water. Then you need to balance. Now, when you look before the arrow, that 2 at the beginning multiplies everything after. So I have 2 zinc, so I need 2 zinc after the arrow. Now, how many nitrogens? I have 2 times 2 of nitrogen. Remember that 3 under the O applies only to the O. But whatever is outside the bracket applies to everything inside the bracket. So the nitrogen, I have 2 times 2 nitrogen, so that's 4. How many hydrogens? Well, that 2 at the beginning multiplies everything after it. But then I have 2 times 6 originally, so I have 2 times 6, that's 12. So that means I have 2 times 12 of hydrogen, so I need 2 times 12 of hydrogen. Now, are the oxygens balanced? Well, how many oxygens do I have before the arrow? I have 2 times 3, 6, times 2, 12. And then I have 2 times 6 of the 6H2O, that's another 12. So I have a total of 24 oxygens. What about after the arrow? I have 2 in the ZNO, plus 8, that's 10, plus 2, that's 12, plus another 12, that is 24. Please pay attention to this kind of balance. A student uses this apparatus to find the heat energy change when ammonium nitrate dissolves in water to form a solution. So he's just dissolving ammonium nitrate and measuring the temperature. So he's saying add 50 centimeter cubed of distilled water to the polystyrene cup, record the initial temperature of the water, add a known mass of ammonium nitrate to the polystyrene cup, stir the mixture until all the solid dissolves, record the minimum temperature of the solution. Now give 2 reasons why the student should stir. What is he doing? He's trying to dissolve the ammonium nitrate in the distilled water, and at the same time he's trying to measure the temperature of the solution. So when we stir, this is to distribute the heat evenly so that the temperature we record is correct, and to dissolve the solid quickly. The diagram shows the minimum temperature of the solution. Notice minimum, that means the temperature is going down. Complete the table by giving the missing information. So the minimum temperature shown on that thermometer, give the values to the nearest 0.1. So what do we read there? That is 19.4. And the difference is 4.0. Do not forget to give it in 1 decimal place. So don't just say the temperature changes 4. The student repeats the experiment again using 50 centimeter cubed water, finds that the temperature change is 3.9 degrees Celsius, show that the heat energy change is about 800 joules. So he wants you to calculate Q. How do we calculate Q? You have to remember that Q is mc delta T. M is the mass. That is the mass of the water, and remember that the mass of water is the same as the volume. So I have 50 grams of water times C is a constant, 4.2, times the temperature change. He already tells me it's 3.9. This gives a Q of 819 joules. Then he says the student uses 2.8 grams of ammonium nitrate in this experiment. Calculate delta H. What is the enthalpy change? How do we get delta H? Delta H is Q over N, so I need to get N. What is the number of moles? He says I have 2.8 grams, and he gives me the MR of ammonium nitrate. So the number of moles is 0.035. Delta H is Q over N. So the Q that we got up there, but the Q that we got up there is in joules. So he wants the delta H in kilojoules per mole. So I need to divide the 819 by 1000. So this gives me 0.819. Divide that by the number of moles, it gives you 23.4. Now I have to put a sign for delta H. Why did I put a positive? Do you remember? The temperature went down. There was a decrease in temperature. Decrease in temperature means the reaction is endothermic, and that means the delta H is positive. Describe a test to show that the ammonium nitrate solution contains ammonium ions. What was test for ammonium ions? Remember, add aqueous sodium hydroxide, warm gently. On warming, bubbles of ammonia gas are given off that turn damp red litmus paper to blue. This is test for ammonium ions. You have to add aqueous sodium hydroxide and warm first. It gives off bubbles of gas that turn damp red litmus paper to blue. In another experiment, the student adds anhydrous copper sulfate to water and he got this results. Explain what the results show about the type of energy change that occurs when anhydrous copper sulfate dissolves in water. Now, what happened here? The initial temperature was 23 point something. The maximum temperature was 28, and that means the temperature of the solution went up or increased. When the temperature rises, that means the reaction is exothermic. Remember, when temperature goes up, reaction is exo. When temperature goes down, reaction is endo. So he's saying explain it is exothermic since the temperature rises. Okay, and that's the end of this paper. I hope this was useful to you. Please go over anything that you are not sure of, and thank you for listening.